September 22nd, 1944, Kirkville, near Cherbourg, France. The first successful undersea fuel pipeline became operational, delivering 56,000 imperial gallons daily from the Isle of Wight directly to Normandy. For German forces, who had built their entire defensive strategy on the assumption that Allied mechanized operations across the Channel were logistically impossible, this revelation would prove as devastating as any military defeat. The Wehrmacht's calculations had seemed unassailable. Without capturing a major port within 72 hours, Allied armor would exhaust its fuel supplies and grind to a halt. This wasn't speculation, but analysis based on German experience. During the 1940 blitzkrieg through France, panzer divisions had repeatedly outrun their fuel supplies despite operating over land with captured French depots available. The 1941 invasion of the Soviet Union had seen entire mechanized corps immobilized by fuel shortages, despite using captured Soviet supplies. How could the Allies possibly sustain operations across 70 miles of treacherous ocean without port facilities? The answer lay in one of history's most audacious engineering achievements, Operation PLUTO, pipeline under the ocean. While German forces measured fuel in carefully rationed liters, calculating every kilometre of movement against tactical necessity, weighing each operation against fuel consumption, the Allies were preparing to pump petroleum directly from England through steel arteries laid on the ocean floor, creating an invisible bridge of fuel that would sustain the largest amphibious invasion in history. Field Marshal Erwin Rommel, the Desert Fox who understood fuel logistics better than perhaps any German commander, had assured the Wehrmacht High Command in May 1944 during a planning conference at Berchtesgaden, the Allies face an impossible logistics challenge. Without ports, their mechanized forces become immobilized steel within 4 days. We need only hold the ports to ensure their defeat. This calculation shaped every aspect of German defensive planning, from the concentration of fortifications around ports to the positioning of reserve formations, from the allocation of artillery to the placement of obstacles on beaches. Rommel's experience in North Africa had taught him the crucial importance of fuel. His Africa Corps had been defeated as much by logistics as by combat, with Italian supply ships unable to deliver sufficient fuel across the Mediterranean. He had personally experienced the frustration of superior tactical positions abandoned for lack of fuel, of pursuing defeated enemies he couldn't catch because his tanks ran dry. Now he believed the Allies would face the same insurmountable challenge, only worse because they had to cross the Channel under fire. Unknown to German intelligence, British engineers had been working on this exact problem since April 1942, when Lord Louis Mountbatten, Chief of Combined Operations, approached Geoffrey Lloyd, Secretary for Petroleum, with a seemingly impossible question: could pipelines be laid across the English Channel? The question arose from the bitter lessons of the Dieppe raid, which had demonstrated the impossibility of capturing a major port intact against determined German defence. The challenge appeared insurmountable. The English Channel presented every possible obstacle to pipeline construction. Depths reached 600 feet in places. Powerful currents could snap steel cables like thread. The seabed was irregular, with rocky outcroppings that could rupture pipes and sandy areas that could shift and expose them. Tides moved massive volumes of water twice daily, creating lateral forces that could displace even heavily anchored structures. Weather conditions were notoriously unpredictable, with storms capable of generating waves that could destroy surface vessels, let alone submarine pipelines. Arthur Hartley of the Anglo-Iranian Oil Company, Britain's leading petroleum engineer, took on the challenge with a team that included some of the finest minds in British engineering. Working with Siemens Brothers, the submarine cable specialists, and experts from the National Physical Laboratory, they developed two revolutionary solutions that would transform military logistics forever. HAIS, Hartley Anglo-Iranian Siemens, represented a fusion of petroleum and telecommunications technology. The design consisted of a 3-inch diameter extruded lead pipe at its core, capable of carrying various petroleum products. This was surrounded by layers of paper tape impregnated with bitumen for insulation, then wrapped with steel tape for strength, creating a structure that could withstand internal pressure while remaining flexible enough to conform to the ocean floor. The outer layer consisted of galvanized steel armor wire, providing protection against external damage while allowing the cable to be handled like traditional submarine cables. The second system, HAMEL, named after H.A. Hammack and B.J. Ellis, two of its designers, took a different approach. It used 3-inch welded steel pipes, similar to those used in the Iraqi oil fields, but manufactured to exceptional tolerances. These pipes could be welded into continuous lengths and wound around enormous floating drums called conundrums, each 30 feet in diameter and weighing 250 tons when loaded with pipe. As tugboats towed these drums across the channel, the pipeline would unspool and sink to the ocean floor under its own weight. The testing phase revealed the enormous challenges. In December 1942, HMS Holdfast laid a trial pipeline across the Bristol Channel from Swansea to Ilfracombe, a distance of 50 miles. The operation took place in winter storms with waves reaching 20 feet. The pipeline was successfully laid and immediately began pumping fuel at 600 pounds per square inch, later increased to 1500 PS1. The success was kept so secret that local fishermen who snagged the pipeline were told they had caught a new type of German mine and should avoid the area. German intelligence had photographed these preparations throughout 1943 and early 1944, but catastrophically misinterpreted them. A Luftwaffe reconnaissance report from July 19, 1944, discovered in Wehrmacht archives after the war, identified the conundrums at Dungeness as probable fuel storage tanks for invasion craft. The massive pumping stations, cleverly disguised as seaside cottages, ice cream shops, garages, and even a mock hotel, were dismissed as civilian structures of no military significance. The German misinterpretation was understandable given their own experience. The Wehrmacht's fuel infrastructure was primitive by comparison. German fuel was still transported primarily in 20-litre jerrycans, the same basic design used in World War I. Rail transport used tank cars vulnerable to air attack. Pipeline technology existed in Germany but was limited to short distances over land, using rigid pipes that required extensive construction time. The concept of flexible pipelines that could be laid like cables was beyond German technical imagination. Admiral Friedrich Rüge, Rommel's naval advisor and one of the Kriegsmarine's most experienced officers, stated definitively in a June 3 memorandum to Army Group B. Laying pipelines across the channel exceeds the technical capabilities of any nation. The pressures involved, the seabed conditions and the installation challenges make such an endeavour impossible. Furthermore, our U-boat surveillance, though reduced, would detect any such attempt. The Allies must rely on conventional tanker delivery, which our forces can interdict. This confidence reflected Germany's own crippling fuel crisis. Since the launch of Operation Barbarossa in 1941, the Wehrmacht had operated under increasingly severe restrictions. The 1943 bombing of Romanian oil fields at Ploiești had reduced supplies by 60%. The refinery at Ploiești alone had provided 600,000 tons annually before the bombing. After, it managed barely 200,000 tons. Synthetic fuel production from coal, despite German chemical expertise at IG Farben and other facilities, never exceeded 124,000 barrels monthly, a fraction of what the Wehrmacht needed. German fuel allocation by June 1944 revealed the desperation. A Panther tank battalion, considered an elite unit, received 300 gallons for a day's operations. This had to cover combat maneuvering, positioning, and potential retreat. Crews were instructed to shut off engines whenever possible, to coast downhill, to avoid unnecessary movement. Tank commanders spent more time calculating fuel consumption than planning tactics. Meanwhile, an equivalent American armoured unit was allocated 30,000 gallons daily, and often received more upon request. The Luftwaffe's situation was even more critical. On D-Day, June 6, 1944, the once mighty German Air Force managed only 319 sorties along the entire invasion front. The Allies flew 14,600 sorties. Each German sortie represented careful fuel calculation, with pilots instructed to avoid unnecessary maneuvering to conserve fuel. American and British pilots, in contrast, flew multiple missions daily, conducted extensive training flights, and never considered fuel availability in their tactical planning. The first 7 attempts to lay PLUTO pipelines failed spectacularly, ironically reinforcing German assumptions about technical impossibility. On August 12, 1944, HMS Latimer began laying a HAIS cable from Sandown on the Isle of Wight toward Cherbourg. The operation proceeded smoothly for 10 hours, with the pipeline unspooling perfectly as the ship moved at precisely calculated speed across the channel. Then disaster struck. An escort destroyer, maneuvering to avoid what its captain believed was a submarine periscope, dropped anchor directly onto the cable, severing it completely. 2 days later, HMS Sancroft attempted another crossing. This time, the pipeline was successfully laid across the entire distance, but as the ship maneuvered to make the shore connection, the cable became entangled in HMS Algerian's propeller, destroying both the pipeline and damaging the escort vessel's propulsion system. Further attempts in late August failed due to different problems. Barnacles had accumulated on the submerged portions of the conundrums, preventing them from rotating properly. Another pipeline broke when it encountered an unexpected rocky outcropping on the seabed. German coastal observers, stationed in bunkers along the Normandy coast, reported these activities to intelligence with dismissive commentary. A report from the 15th Army dated August 28 stated, "Enemy naval units conducting repeated failed operations off Cherbourg. Purpose unknown, but results clearly unsuccessful. Multiple vessels observed recovering equipment from water. Assessment, failed attempt at minefield clearance or salvage operations. No threat to defensive positions identified." Even more telling was a Kriegsmarine intelligence assessment from September 5th, Allied naval activity in Channel consistent with attempted cable-laying operations, possibly for communications. Multiple failures observed. Weather and current conditions make successful cable-laying highly improbable. Continue monitoring, but assign low priority. The breakthrough came on September 22nd, when the first HAIS pipeline from Cherbourg to the Isle of Wight became operational, delivering those crucial 56,000 imperial gallons daily. The pipeline had been laid successfully by HMS Latimer in a near-perfect operation, with weather conditions ideal and all equipment functioning flawlessly. 9 days later, on September 29th, HMS Conundrum II successfully laid a HAMEL pipeline, adding another 70,000 gallons daily capacity. By October 10th, when HMS Sancroft successfully laid a pipeline from Dungeness to Boulogne in just 5 hours, the system was delivering hundreds of thousands of gallons daily. This operation was particularly significant because it demonstrated that pipeline laying had become routine. What had seemed impossible in August was now accomplished in less time than it took to conduct a standard naval patrol. Eventually, 17 pipelines would cross the channel, 11 HAIS and 6 HAMEL lines, creating an underwater network of steel arteries feeding the Allied advance. German discovery of Pluto's existence came gradually and traumatically. In late September, Wehrmacht engineers examining captured Allied fuel depots near Boulogne found something that defied explanation. The depot contained massive fuel terminals with no visible supply source. There were no storage tanks of significant size, no harbour facilities for tankers, no rail connections, yet thousands of gallons flowed continuously into distribution points. Major Hans Dietrich, a petroleum engineer from IG Farben who had designed synthetic fuel plants before being conscripted into the Wehrmacht's supply corps, was tasked with investigating. His October 15th report to OKW, discovered in the Bundesarchiv Militararchiv after the war, reveals the growing German awareness. The enemy is receiving fuel through means we cannot identify. Flow rates suggest pipeline delivery of approximately 800 tons daily at this location alone. Interrogation of captured American and British personnel yields consistent claims of underwater pipelines from England, which our engineers initially deemed technically impossible. However, physical evidence contradicts our assumptions. The fuel continues to flow from connection points that emerge from the channel itself. Recommendation: urgent technical investigation required. The psychological impact on German forces was immediate and devastating. Panzer crews who had been trained at the armour school at Putlos to conserve every drop of fuel, who had practiced shutting off engines while coasting downhill, who calculated fuel consumption against tactical necessity with obsessive precision, watched American tankers leave engines running continuously. Tank commanders reported American armor units conducting training exercises that consumed more fuel than German combat operations. A captured diary from an unnamed 12th SS Panzer Division tank commander, dated October 19, 1944, provides intimate insight into the German reaction. Watched American Shermans practicing maneuvers for 3 hours continuously near Aachen. They burned more fuel in this training than we receive for a week of combat. Approached their supply sergeant during temporary ceasefire to collect wounded. Asked about fuel allocation. He laughed and said they never measure it, just radio for more when tanks run low. How do you fight an enemy that doesn't count fuel? Our Panther is superior in every way except one. It sits idle while their inferior Shermans never stop moving. The full scope of Allied fuel logistics became undeniable during Operation Queen, the November offensive toward the Roa River. German intelligence, through careful observation and captured documents, calculated that American forces in this sector alone were consuming 1.2 million gallons daily. This single offensive was burning more fuel than the entire Wehrmacht Western Front received in a month. The Ninth Army's planned counterattack was cancelled when fuel allocation permitted only 4 hours of operations for the assembled armour. Meanwhile, American artillery fired continuous barrages for 72 hours, each shell delivered by fuel-consuming trucks in endless convoys that never seemed to diminish. General der Panzertruppe Hasso von Manteuffel, one of Germany's most capable armour commanders who had distinguished himself on the Eastern Front, reported to Hitler on November 20th from his 5th Panzer Army headquarters, "The enemy possesses unlimited mechanical movement. They conduct reconnaissance with vehicles where we must use foot patrols to save fuel. Their artillery moves frequently to avoid counter-battery fire. Ours remains static because we lack fuel to relocate. Our tactical superiority becomes meaningless when they can sustain operations indefinitely while we measure movement in litres. This is not a disadvantage that leadership or will can overcome. This is material superiority that renders traditional military skill irrelevant." Hitler's response, recorded in the OKW War Diary, was predictable but revealing: rage against defeatist generals and orders to increase production through will and national spirit. He ordered Speer to double synthetic fuel production within 30 days, a demand that Speer knew was impossible. The synthetic fuel plants at Luna, Bohlen, Politz and Brooks were operating at barely 20% capacity when not completely shut down by bombing. The October production of 17,000 tons was achieved only by cannibalizing equipment from damaged facilities. This monthly production was what Pluto would soon deliver in less than 4 days. The Battle of the Bulge in December 1944 exposed the fatal consequences of Germany's fuel poverty versus Allied abundance in the starkest possible terms. The entire Ardennes offensive, Germany's last major operation in the West, depended on capturing American fuel dumps intact. The operational plan, personally approved by Hitler, explicitly stated, "After day 3, advancing units will operate on captured enemy fuel." This wasn't optimistic planning but desperate necessity born from mathematical reality. The numbers were merciless. The assembled German forces for the offensive, 6 Panzer divisions, 5 Panzer Grenadier divisions, and 18 Volksgrenadier divisions, required approximately 2 million gallons of fuel to reach Antwerp, their ultimate objective. They possessed less than 400,000 gallons. The plan literally required capturing 5 times more fuel than they possessed, assuming no combat losses and perfect efficiency. SS Obersturmbannführer Joachim Peiper's Kampfgruppe, spearheading the 6th Panzer Army's assault with 72 tanks, including the newest King Tigers, carried enough fuel for 30 miles of movement. The operational plan required advancing 125 miles to the Meuse River. Peiper's force needed to capture American fuel supplies at Stavelot, Trois-Ponts and Spa to continue. When American engineers destroyed these dumps, some containing over 2 million gallons each, Peiper's elite force was immobilized within 72 hours of the offensive's start. The arithmetic of failure was simple and brutal. A King Tiger consumed 280 gallons per 100 miles on roads, often over 500 gallons in combat conditions. Piper's battalion of King Tigers alone needed 50,000 gallons to reach the Meuse. They had less than 8,000. The finest heavy tank unit in the German military was reduced to abandoning their vehicles and walking back to German lines through the Ardennes forest in bitter winter weather. Meanwhile, the American Red Ball Express truck convoys were delivering 400,000 gallons daily to units opposing the German offensive. The contrast was captured by an American quartermaster officer who reported, "German prisoners kept asking where all our fuel came from. When we told them about pipelines under the ocean and truck convoys running 24 hours, they didn't believe us." One German officer said it was impossible. "I showed him our daily fuel receipt, 300,000 gallons delivered that morning. He broke down crying." By January 1945, German intelligence had finally confirmed the impossible reality of Operation PLUTO through captured technical documents and systematic interrogation of Allied prisoners. The specifications stunned Wehrmacht engineers who had considered themselves masters of military technology. The pumping stations at Dungeness and the Isle of Wight employed Byron-Jackson centrifugal pumps, manufactured in California and shipped to England, each capable of generating 1,500 pounds per square inch of pressure. These stations could deliver 3,500 tons daily through a single pipeline. The pipeline construction itself represented engineering that exceeded German capabilities. The HAIS cable's lead pipe core was manufactured to tolerances that exceeded German submarine battery cases, crucial components that received the highest manufacturing priority. The steel tape wrapping was stronger than the armor plate used on German tanks, yet flexible enough to coil around drums. The armored wire protection surpassed anything in German cable manufacturing, using special alloys that Germany couldn't produce in quantity. Most devastating was the discovery that this represented standard Allied engineering, not miracle technology. The pumps were commercial models adapted for military use. The pipeline materials were manufactured by civilian companies using existing industrial processes. The laying techniques were adapted from submarine cable operations that had been routine since the 19th century. The Allies had solved the impossible problem through industrial capacity and engineering competence, not through revolutionary breakthrough. Professor Ferdinand Porsche, designer of the Tiger tank and one of Germany's most celebrated engineers, was brought captured PLUTO documentation in February 1945. His analysis, found in his personal papers donated to the Porsche Museum, was devastating. "The steel required for 1 mile of their pipeline exceeds our monthly allocation for all military vehicles. They have laid 500 miles. The lead in their pipes exceeds our submarine battery production for 6 months. They use it for fuel transport. The pumps each exceed our largest industrial units in capacity and pressure. They have dozens operating continuously. This is not a technological advantage we can overcome. It is technological dominance from a fundamentally superior industrial civilization." The human dimension of this disparity created countless individual tragedies that illustrated the larger catastrophe. Wehrmacht medical units reported in January 1945 that they were abandoning wounded soldiers because ambulances lacked fuel for evacuation. Units were forced to choose between using their last fuel to retreat or to evacuate casualties. Most chose retreat, leaving wounded comrades to become prisoners. Meanwhile, American forces flew medical evacuation missions using light aircraft, each flight burning more fuel than a German field hospital received monthly. German soldiers froze in winter positions without fuel for heating, while American troops complained in letters home about excessive warmth from gasoline-powered tent heaters that ran continuously. Letters from German soldiers captured in early 1945 reveal the complete psychological collapse caused by fuel disparity. A Fallschirmjäger sergeant wrote to his wife in a letter that was never sent, "The Americans wash their jeeps daily with heated water. They run engines to charge radio batteries while we have no batteries at all. They burn gasoline to heat coffee, to warm food, to dry clothes. We haven't seen fuel for our vehicles in 2 weeks. This isn't war anymore. It's industrial extermination by an enemy who has everything while we have nothing." Albert Speer, visiting the Western Front in January 1945 on Hitler's orders to assess the situation, witnessed the futility firsthand. In his post-war memoirs, Inside the Third Reich, he recalled, I watched American vehicles streaming endlessly toward the front, each burning fuel that would have supplied a German company for a week. When I learned they were pumping this fuel from England through underwater pipelines, I knew the war was not just lost, but had been lost from the moment we failed to understand what kind of enemy we faced. We had prepared for war against nations like ourselves, with similar limitations. We faced instead an industrial colossus that could perform engineering miracles as routine operations. The technical details of Pluto, when fully revealed through post-war analysis, showed the true chasm between Allied and German industrial capacity. By March 1945, 17 pipelines crossed the Channel, creating over 500 miles of underwater steel highways. The system employed approximately 1,000 specialist personnel operating in 3 shifts around the clock. Over 100 pumping stations, from major facilities to small booster stations, maintained pressure throughout the network. The Dumbo section from Dungeness to Boulogne alone consisted of 4 3-inch HAIS cables and 7 HAMEL pipes, capable of delivering 8 100,000 gallons daily. The lines were laid in depths ranging from 60 to 180 feet, crossing shipping channels, tidal races, and rocky outcroppings. The engineering required to maintain consistent pressure while accounting for depth changes, temperature variations, and tidal movements exceeded anything in German industrial experience. The redundancy built into Pluto particularly amazed German engineers studying captured documents. Multiple pipelines meant that mechanical failures, always expected in such complex systems, never stopped fuel flow. When winter storms in December 1944 damaged 3 pipelines simultaneously, the system continued delivering 800,000 gallons daily through the remaining lines. Repair crews fixed the damaged sections within 96 hours, while operations continued uninterrupted. This philosophy of building excess capacity as insurance rather than waste was incomprehensible to German planners accustomed to scarcity. German military doctrine emphasized concentration of force, using every available resource at the critical point. The concept of maintaining reserve capacity, of building redundancy into systems, of accepting inefficiency for reliability, was foreign to minds shaped by perpetual shortage. German attempts to interdict Pluto came too late and proved pathetically inadequate. In January 1945, the Luftwaffe's few remaining bombers attempted to attack pumping stations at Dungeness and Shanklin-Chine on the Isle of Wight. The raids required careful planning and consumed precious fuel that could have supported ground operations. 43 bombers took off. 11 were shot down by fighters, 7 by anti-aircraft fire, 6 turned back with mechanical problems. The surviving aircraft dropped their bombs on targets that proved to be camouflaged decoys. The actual pumping stations, dispersed and hardened, continued operating without interruption. The Kriegsmarine's efforts were even more futile. Admiral Karl Dönitz ordered his last operational U-boats to locate and attack the pipelines, but they lay invisible on the channel floor under tons of water and accumulated sediment. U-boat commanders reported that even if located, they possessed no weapons capable of damaging pipelines at depth. The submarines themselves operated on such critically limited fuel that some attempted patrols with only enough diesel to return to port if they proceeded at minimum speed and avoided all combat. U-873's war log, captured when the submarine surrendered in May 1945, recorded the futility. Ordered to locate and destroy enemy fuel pipelines in Channel. Searched for 7 days using passive sonar and visual observation. Found nothing. Fuel state critical. Batteries failing. Forced to return having accomplished nothing. The pipelines remain invisible, invulnerable, incomprehensible. By February 1945, Allied engineers were preparing to extend pipelines across the Rhine River into Germany itself. German commanders realized with horror that the Allies could theoretically run pipelines anywhere their armies advanced. The Rhine, Germany's last major natural barrier, could be bridged underwater as easily as the Channel. This prospect represented the ultimate defeat, an enemy that could project not just military force but industrial infrastructure across any distance, over any obstacle, under any conditions. The numbers told the final story with mathematical brutality that no amount of propaganda could obscure. Between September 1944 and May 1945, Operation PLUTO delivered 172 million gallons of fuel to Allied forces. The entire German fuel production for 1944, military and civilian combined, totaled 23 million gallons. The Allies pumped more fuel through undersea pipelines in 2 months than Germany produced in its entire territory for the entire year. Post-war analysis revealed additional ironies that deepened German humiliation. PLUTO had experienced numerous problems and never achieved its designed capacity. The first operational pipeline didn't function until September 22nd, 3.5 months after D-Day. The system delivered only 8% of total Allied fuel needs, with the remainder coming from conventional tanker delivery and the Red Ball Express truck convoys. Yet even this flawed, partially successful system exceeded Germany's entire fuel infrastructure in every measurable way. General Heinz Guderian, creator of Blitzkrieg doctrine and Germany's foremost expert on armoured warfare, provided the most perceptive analysis in his post-war memoirs. We invented modern armoured warfare. We showed the world how to use tanks, aircraft and infantry in devastating coordination. We developed the tactics, the communications, the doctrine that every army copied, but we never solved the fundamental problem: how to fuel such operations continuously. The Americans and British didn't invent armoured warfare, they invented something more important, the ability to sustain it indefinitely. We won battles, they won the war. Field Marshal Gerd von Rundstedt, reflecting on his defeat as Commander-in-Chief West, stated during his interrogation at Bad Mondorf, "Your PLUTO pipelines were not your greatest achievement. Your greatest achievement was considering such pipelines normal, merely another engineering problem to solve. We Germans prided ourselves on technical excellence, on engineering precision, on scientific advancement. But we thought small, tactically. You thought strategically, industrially. You didn't defeat our army. You defeated our entire conception of warfare." The psychological impact extended far beyond military implications. German soldiers who had maintained faith in ultimate victory despite retreats and bombing now understood they faced an enemy with unlimited industrial capacity. If the Allies could build pipelines under the ocean while simultaneously producing 300,000 aircraft, 88,000 tanks, and millions of vehicles, what hope existed for Germany? The revelation of PLUTO shattered not just military morale, but the entire ideological structure of Nazi superiority. A captured SS officer's letter from March 1945, found in Allied intelligence files, summarized the despair. "We were told we were the master race, superior in all things, yet we cannot fuel our tanks while our enemies pump fuel across the ocean floor. We were told German engineering was supreme, that German science led the world, yet they build underwater pipelines while we cannot maintain rail lines under bombing. We were told our will would triumph over material disadvantage, but will cannot create fuel from nothing, and they have everything while we have nothing." The discovery of PLUTO's existence spread through German ranks like psychological poison. Wehrmacht propaganda had assured soldiers for years of German technical superiority, of the inherent weakness of democratic nations, of the inevitable triumph of authoritarian efficiency over democratic chaos. The revelation that the Allies had accomplished something German engineers deemed impossible while considering it routine shattered this mythology completely. General Wilhelm Keitel, chief of the Wehrmacht High Command, received reports of collapsing morale directly attributed to PLUTO's psychological impact. One report from the 7th Army, dated March 10, 1945, noted, "Knowledge of enemy fuel pipelines under the ocean has convinced troops that American industrial capacity exceeds all propaganda claims. Soldiers openly question what other impossible capabilities the enemy possesses. Requests for fuel are met with bitter laughter. Tank crews refuse to advance knowing their vehicles will be abandoned within hours." The last German military assessment of PLUTO came from Field Marshal Albert Kesselring in April 1945. His report to Hitler, one of the last strategic assessments of the war, stated, "The enemy has industrialized logistics itself. They do not transport fuel. They pipeline it across ocean floors. They do not worry about consumption. They assume unlimited supply. They do not calculate fuel for operations. They simply conduct operations assuming fuel will flow. This represents a form of warfare we never conceived and cannot counter. We are fighting the past war while they are fighting the future one. Pluto's legacy extended far beyond the war's end. German military professionals studying at NATO staff colleges in the 1950s focused obsessively on logistics and supply chain management, traumatized by watching enemies with unlimited fuel defeat forces with superior tactics and weapons. The Bundeswehr, established in 1955, emphasized logistics and sustainability over tactical brilliance. Every German military operation since has been planned with fuel supply as the primary consideration, not a secondary concern. Hans Speidel, Rommel's former chief of staff who later became NATO commander of Allied land forces Central Europe, wrote in 1960, "Pluto taught us that modern war is won in factories and engineering offices, not on battlefields. The side that can sustain operations longest prevails. The side that can transform industrial capacity into military capability most efficiently triumphs. We learned this lesson at the cost of our nation's destruction. We will never forget it." The 17 pipelines of Pluto were decommissioned in 1946, the recovery operation beginning in September of that year. The salvage effort itself demonstrated Allied industrial efficiency. Using the same ships that had laid the pipelines, HMS Latimer, renamed Empire Ridley, HMS Holdfast, renamed Empire Tor, and others, crews recovered 22,000 tons of lead and 3,300 tons of steel. The materials were desperately needed for European reconstruction, with the lead going primarily to rebuilding electrical infrastructure and the steel to railway rehabilitation. But the system's true legacy was the complete transformation of military logistics thinking worldwide. For German officers who had dismissed supply as a mere support function, secondary to operations and tactics, Pluto delivered brutal education that would reshape military doctrine globally. Logistics was strategy. Industrial capacity was military power. The ability to sustain operations indefinitely was more important than tactical brilliance or individual courage. The story of German forces discovering Operation Pluto ultimately reveals the collision of two incompatible concepts of warfare. Germany had perfected traditional military excellence, professional officers trained at the Kriegsakademie, superior tactics developed through careful study, advanced weapons like the Tiger and Panther tanks, disciplined soldiers indoctrinated from youth. The Allies had industrialized warfare itself, transforming it into applied industrial capacity, where victory went not to the best soldiers, but to the best production and distribution systems. In the final analysis, Pluto's 172 million gallons represented far more than fuel. Each gallon was proof of Allied industrial supremacy, flowing through steel arteries laid on the ocean floor by nations that had mobilized their entire productive capacity for victory. The German military machine, for all its tactical brilliance demonstrated in France, Poland, and Russia, for all its technical innovation in tanks, rockets, and jets, for all the courage of its soldiers, was defeated by pipelines it couldn't imagine, carrying fuel it couldn't match, from an enemy whose industrial power exceeded not just German resources, but German comprehension. The last documented German reaction to Pluto came from an unknown Wehrmacht colonel whose interrogation transcript was found in the US National Archives. Asked why Germany lost the war, he responded, "You could pump fuel from England to France under the ocean. We couldn't pump fuel from Berlin to Hamburg over land. You had already won the war before the first shot was fired. We just didn't know it yet. We brought a knife to a gunfight, but worse, you brought a factory to manufacture unlimited guns." Operation Pluto stands as history's supreme example of logistics as strategy. While German forces counted litres and calculated kilometres, while tank crews siphoned fuel from disabled vehicles and commanders cancelled operations for lack of fuel, Allied forces pumped unlimited petroleum through underwater pipelines, turning the English Channel from a protective barrier into a highway for the fuel that would power victory. The German discovery of this reality marked not just military defeat, but the complete collapse of everything they had believed about warfare, technology, and their own superiority. The Third Reich, which had promised thousand-year dominance through racial superiority and will, was defeated by superior plumbing, by engineers who could lay pipes on the ocean floor, by workers who could manufacture pumps and pipelines faster than Germany could produce rifles. The pipelines kept pumping until May 1945, continuing for 5 days after Germany's surrender on May 8th, a final symbol of Allied industrial momentum that could not be stopped even by peace. German engineers, now prisoners of war, were sometimes employed in dismantling the system they had never believed possible. As they worked, many reflected on the elegant simplicity of what had seemed impossible: steel tubes on the ocean floor, carrying the fuel that had powered their defeat. One German engineer, whose name is lost to history, reportedly said while working on pipeline recovery, "We designed Tigers and Panthers, the finest tanks ever built. They designed pipelines to fuel Shermans forever." Which was really the superior engineering? In the end, Germany's finest military minds learned the hardest lesson of modern warfare: that courage, skill, and superior weapons mean nothing without the fuel to operate them continuously. The Allies had solved this equation with pipelines under the ocean, pumps that never stopped, and the industrial capacity to build redundancy into everything. Germany never solved it at all, fighting to the end with horse-drawn transport alongside Tiger tanks, with Mi-262 jets grounded for lack of fuel while inferior Allied aircraft flew continuously. That difference, more than any battle or campaign, more than any general's brilliance or soldier's courage, determined the war's outcome. The 17 pipelines of Pluto delivered victory 1 gallon at a time, flowing from England to France through steel arteries laid on the ocean floor, unstoppable as the tide itself, carrying not just petroleum but the industrial might of democratic nations mobilized for total war. Against this force, the Wehrmacht's tactical excellence and advanced weapons proved as futile as swords against machines. German troops who had dismissed logistics as secondary to operations learned too late that in industrial warfare logistics was everything. The side that could sustain operations longest would win. The side that could transform industrial capacity into military capability would triumph. The side that could pump fuel under oceans while the enemy counted litres had already won before the first battle was fought. The story of Pluto is ultimately the story of how World War II was won. Not through brilliant strategy or superior tactics, not through courage or advanced weapons, but through the mundane ability to deliver fuel continuously to machines that consumed it voraciously. The Allies understood this. Germany never did, and in that failure of imagination lay the seeds of the Third Reich's destruction, defeated not by armies but by pipelines, not by generals but by engineers, not on battlefields but on the ocean floor where steel tubes carried the fuel that powered victory.